So when it comes to geometric sequences now, so here we are talking about geometric sequences. So we're just saying that in a geometric sequence, each term is going to be multiplied or divided by the same number. So these ones right here, they are looking at these geometric sequences. So you're saying that each each term, say that you're going to be using the word term. So each term is divided or multiplied by the same number. Let's say, for example, here we've got 2, 6, 18, and 54. If you notice, we've got this 2 and this 6. So if you say 6 by 2, we've got a 3. So each term is being multiplied by 3. We've got this 6 and this 18 and this 54. So each term is being multiplied by 3. So now we are saying that the number multiplied by each term is called the common ratio. So for geometric sequence, we're now going to be having what you call a common ratio. If it is arithmetic sequence, you're going to have a common difference. So you're going to be using a formula that now says AR to the power of n minus 1, where A is still the first term, R is now the common ratio, and n still stands for term number. So this one is going to be the formula that you're going to be using for geometric sequences. So let's look at the question that we have here. So we are told that we've got 2, 6, 18, and 54. So we're saying that what is A? A is the first term, which is 2. Okay, let me rewrite it like this. Okay, so we've got 2 times R. So our R is now going to be 3. That is the difference that we have, because we are saying we've got our 2 and our 6. There's a difference of 3 if you're going to be multiplying them. Same goes with 6 and 18, as well as 18 and 54. So we've got our 2, 3, and then we've got our n minus 1. So now let's say that the question says that find the fifth term. So if you're now asked to find the fifth term, it means that where there is an n, you're now going to put a 5. So that it becomes 2, 3, 5 minus 1, which is going to be 2 bracket 3, 5 minus 1, which is 4. So then you can simplify this 3 to the power of 4. So before you say 2 times 3, this 3 has to deal with its 4 first. So now we've got 2 times 3 to the power of 4, which is 81. So now we've got 2 times 81, which is 162. So if you're asked to find the nth term, you're going to be using this formula there. But now if you are given a value, you're now going to be using that formula to find whatever that you're going to be looking for. So now here what you call quadratic sequences. So this one is going to be for recognizing the types of sequences. You're going to have different types of sequences. So we can have what you call the arithmetic sequence. For example, 2, 4, 6, 8. There's a difference of 2. We're adding 2. If we've got 3, 9, 27, 81, we are multiplying by 3. So that one is now going to be a geometric. But what about if we've got something like this? We've got 1, 4, 9, 16, and 25. Because we are saying that for arithmetic, the difference is the same from one consecutive term to the next consecutive term. If it is for geometric, it's also going to be the same when you are dividing or multiplying. But for quadratic, there's going to be different changes. There are going to be many differences. So you're saying that some sequences do not have a constant first difference. So let's look at the example that we are given there. So in our example, we are given 2, 6. So we've got 2, 6, 12, 20, and 30. To go from 2 to 6, there is 4. From 6 to 12, we're going to add 6. 12 to 20, we're going to add 8. 20 to 30, we're going to add 10. But here, as you can see, we don't have a constant difference. So what we are going to do with these questions, since we have what the first differences, we have found the first differences, right? Just like we did with the arithmetic, you're going to find your difference. But if it was for the arithmetic, would have noticed that the differences are going to be constant, but these ones are not. So you're going to find the second difference. You're going to find another difference, right? So to find another difference, we're now saying here we've got 4 and 6, right? So again, you're going to find the difference. So 6 minus 4, that is 2. So we're adding 2. 8 minus 6, that is also going to be 2. 10 minus 8, that is also going to be 2. So we're saying that because the second difference is constant, this is a quadratic sequence. And a quadratic sequence is the formula an squared plus bn plus c. So here we've got a way to recognize sequences. How do we recognize a sequence? If it is arithmetic, it has a common difference. If it is geometric, it has got a constant ratio. If it is a quadratic sequence, it's going to have a constant second difference, not the first one. So for the other two, arithmetic and geometric, we find the difference once. But for quadratic, you're going to look for it twice. So you're saying that it's now going to have a constant second difference. So we're saying that when you're asked to find, okay, so here we've got some exam tips that we have. So one, you're saying that when you're asked to find the nth term for a simple arithmetic sequence, one, find the common difference, and then you put it in front of the n. Then you're now going to find the adjustments that are required. For example, here we've got 8, 13, 18, 23. What is the difference? From 8 to 13, we've got 5, so you're adding 5. From 13 to 18, also adding 5. 18 to 23, we are also adding 5. So the difference is going to be 5. So now the start, you're going to take your 5n. Then you're now going to compare the first term. So since we know that n stands for a term, we are saying that let's compare the first term. So 5 times 1 is going to remain as 5. But if you notice with this question there, the sequence starts at 8. There's an 8 there. So what you're now going to do is you're going to say 8 minus 5. You're going to be sort of like looking for a new first term because you already have 8 as our first term. So if we subtract 5, we're going to get another first term. Because if you say 8 minus 5, it's going to be 3. From 3 to 8 is still positive 5. So this means that it's going to become 5n. Where did the 5n come from? This is a quick way to find your answer as compared to using the arithmetic formula. But you can still use that formula. Both answers are going to be correct. For this one, what you are doing is that you're going to say 5. No, you're going to say the common difference. In this case, it was 5. So it becomes 5 times the nth term, which is n, plus 3. 3 being the new first term that we just created now. So a quick summary. we say that for arithmetic, we're going to be looking for the common difference. For quadratic, we're going to be looking at the second difference. For ratio, for geometric, it's going to be ratio, so it's written here. If you're looking for arithmetic, if it's arithmetic sequence, you're looking for the difference, you're using the common difference. For geometric, is the common ratio R. For a quadratic, we're now looking at the second difference. So the first time, we're not going to have a constant difference. But if you find for the second time and you get a constant difference, that means that you are dealing with a quadratic sequence. So for the formulas, for arithmetic, we say that you are going to be using the formula a plus n minus 1 d. That is going to be the Tn. For a geometric sequence, Tn is going to be equal to AR n minus 1. And then for quadratic sequence, it's now going to be Tn is equal to an squared plus bn plus c. And then now we've got some questions on what we're looking at. So you can just use any of the two methods that you mentioned. So let me start with the first one. Then I'm just going to do the first one. We've got 0, 4, 8, 12, 16. Let's find the difference. From 0 to 4, there's 4. From 4 to 8, there's 4. From 8 to 12, there's 4. From 12 to 16, there's also 4. So that one is going to be arithmetic. So now we are going to say there are two ways. Let's start with the formula first. A plus n minus 1 d. What is A? A is going to be the first term, which is a 0, plus n minus 1 d. D being the common difference, which is 4. So that means that we are now got 0 plus 4 times n, which is 4n, 4 times negative 1, which is negative 4. So meaning that the common difference is going to be 4n minus 4. And if we were to use the second method that we introduced, we're now going to say the common difference, which is positive 4, and you put an n. And then you're going to look for the term that comes before 0. So the one that comes before 0, you're just going to say minus 4. 0 minus 4, that is minus 4. So the term that you're looking for is minus 4. So it just becomes 4n minus 4. So you can just use any of these two methods. The answer is still going to be the same. And we use these ones. If you are trying to find the nth term, we are trying to find the nth term. We're not looking for the sum or anything. If you are trying to look for the sum, it is going to be a completely different formula. So that is going to be how we deal with sequences.